So I am Lorrie Rand, and since I've only got 20 minutes, I won't go into who I am in a big way, but I will say that I'm part of a seven-person team of, up until very recently, we were all women. Now we have actually added our first male person on our team. And we are based in Halifax, and we specialize in sustainable residential renovations, deep retrofits, and passive house new construction. And so I'm going to share a very special project today. I'm going to be talking about total cost of building ownership uh, a- and return on investment, but I need to contextualize that for you a little bit. So I'll tell you about the construction that we did to this building. So we actually bought this building in late 2021. And over the course of the last 3.5 years, and we were not in construction that whole time, but COVID construction, there were lots of delays and issues. But we have recently completed the retrofits um, to our new office. And so this is an 1850s house in Halifax. It's about 1,800 square feet, not including the kind of spider cave that is the basement. And it was completely uninsulated, had single pane windows. Some of them were actually original windows. And it's got a party wall. So we've got like a little bit of complexity related to that. And um, just a little shout out to our project partner. We received quite a bit of support on this, more than the typical commercial retrofit incentive through Nova Scotia's Efficiency Nova Scotia. Uh, I'm gonna assume that most people know what Passive House is, but just to make sure, the Passive House standard was established to deliver the highest quality building that we can with respect to comfort and health, energy efficiency, and economics. And so we do that through investing in a very durable building envelope with an continuous airtight envelope, continuous insulation, thermal bridge-free detailing, high performance windows and doors where we manage the solar energy. So we're not maximizing it, we're managing it, optimizing it. And with all of that excellent airtightness, we need mechanical ventilation with heat recovery. So that's how we make a passive house. This is what the building looked like when we bought it. So the building actually has, when we got into the TCBO calculations, we realized it had about a $500,000 maintenance backlog. Many of the other people who were going to buy the building were planning to knock it down, but we didn't want to. We wanted to do our retrofit. So the first thing that we did was we got an Energuide audit, and we learned that it had about 24 air changes per hour, and it was responsible for about 72.5 tons of greenhouse gases every year. So it was quite a leaky building in quite bad shape. So what we did to the building, and I apologize, it's so new. We've really just recently finished the project, so we don't even have photos yet of the what it looks like now. But we will. So if you pay attention to find me on LinkedIn or something, you'll see some photos eventually. Um, we brought the walls up to effective R value 24, the roof to R65, and the floors to R24. So we insulated the basement floor, and there was a little part of the building that was a slab on grade, but we were that was it was not a slab on grade. It was joist on dirt. So we also made that uh, R24 with a new slab. And our windows are Veta triple glazed passive house windows, and we added heat pumps for heating and cooling. The building was actually all electric already, but with just massive radiators and an Alnor high efficiency ERV. And so that you understand the kind of relative impact of each of those measures. Um, this graph sort of going from right to left, where this is the heating demand. So the existing heating demand was reduced in our energy model. by about a third by going to an air tightness of 1 air change per hour, and then adding passive house windows and doors, and a little bit, we increased the area of the south-facing glass in this work. Um, that saved another third, of the, heating demand, and then insulating walls and roof, another third. And so this is our energy balance diagram. And so the top row or the top bar is the energy balance before, and the lower bar shows how much we can, compressed the energy use of the building. And right now, we actually haven't, as of our last blower door test, we have not yet hit our blower door target. And so we haven't achieved all the savings that we're going to. Um, that's a long story. You can ask me about it if we don't run out of time. But where we are now, we have saved about 88% of the heating energy demand, 86% of the total energy, and 90% of the greenhouse gas emissions from the building. All of the work is done, but we haven't, we couldn't quite get the basement where we needed it, and the basement isn't even really isn't in the passive house envelope, but we're still trying to get there. Um, so all in, we've saved, we've almost got to our target. So again, we have saved just nearly 90% in heating and energy, and 90% in GHGs, and we're quite optimistic that we're going to get, a couple more percentage points on each of those once we have our next blower door test, which is very exciting. Total cost of building ownership. Financial evaluation through simple payback analysis really works well for simple measures like switching a boiler to a heat pump or for adding solar panels. But when we want to understand the life cycle costs of a complex project like a whole building retrofit, where multiple interrelated components and systems impact the performance, we need something more robust, a more robust tool. And that's what total cost of building ownership does. And so we need to be evaluating all of the reasonably anticipated expenditures on the building. And we need to be looking at those for the anticipated useful life of the building. So, the kind of way that a lot of decisions with buildings get made, um, are looking only at maybe a 15 or 20-year time period. And so what the TCBO does is it looks at the capital cost, the financing and interest, property taxes, insurance, energy costs, and other utilities, and maintenance capital. And maintenance capital is different than maintenance in that it is the cost to replace the major components. So, every, say, 30 years, you're replacing your roof, and every maybe 20 years, you're replacing your heating equipment, things like that. Those things really add up over the life of a building, and if we don't consider them, then our understanding of what the building costs is going to be a problem. Because we're architects, we work with Jim at Nosted with CFAR Analytics on our total cost of building work. And for this project, we wanted to look at a code minimum retrofit and also a code minimum new build, comparing with our project. And we did our project with some grants from Efficiency Nova Scotia. So we were analyzing it kind of with and without those grants. And what the analysis really showed is that our investment with the grant, even without the grant, was the most favorable, in the 60-year life cycle costing of the building. So here's a kind of the graph or the comparison between those options, but I do want to dive in. So I'm just going to go quick to a little bit more granular numbers. Everybody always wants to know, well, what the starting point was. These are the estimated costs for each of those measures. None of these projects is as high as this because this actually includes the $500,000 that we paid for the building. Um, so um, so the code minimum retrofit ended up being about 100 grand less than the passive house retrofit. But um, when we factor in our costs, so this is our utility cost comparison, you can see that the passive house retrofit, it's going to cost about half as much in utilities, in electricity primarily, compared to the other options. And when we look at maintenance and maintenance capital, these are really impactful as well. Our passive house actually costs more. This is an anomaly because we were upsold on our mechanical systems. Our mechanical contractor didn't believe how small it needed to be. So we're paying too much for maintenance capital on our heat pumps. But this is a measure that a lot of people underestimate, and so I really wanted to highlight the impact of maintenance capital particularly. And so we don't just have costs, we also have equity in our buildings. And so we also can look at that with a TCBO analysis. And so these are how the three compare. The new build is worth more than the passive house retrofit. I don't really understand that because our building is good as new, but that's what the numbers say. Um, but then when we, balance out, so we show the combined impact of the equity and the expenses on the building. Code minimum retrofit loses in a big way. Code minimum new build and a passive house without the grants really is kind of you almost break even. And the passive house project with the retrofit was the best investment with us. So that was me going through TCBO in lightning speed, and I will happily answer questions at the end of this for anybody who has them.
Amazing. So we'll bring you back on after. And so
Yeah.
now we're just going to hear from Mark first. Mark, take it away.
Thanks so much, Laura. I will share my screen and thanks for the invite from Laura and Chris to join you all here. I see some familiar names and certainly appreciate the chance to chat with you all. I'm going to see if there's still some gremlins um, in the Zoom app here, and let me know if you can see something, and I'll dive in. In worst case, I don't mind. I can make it work either way.
So
Do you
we
see
can
something there?
we can still see your speaker's notes though.
Let me just flip that. That's easy. How's that?
Nailed it.
Alrighty. Okay. So thanks again for having me here. I'm Mark Pauls. I'm the department manager of facilities and security at Manitoba Hydro. We're fairly well known in the facilities world, and we've certainly been involved with SUM over the years and presented about one of our flagship projects, Manitoba Hydro Place. I promise I'm not going to spend a lot of time talking about that building because I think there was a lot of people locally who've heard a lot about that project. But overall, we do have 140 buildings. We have 200,000 square meters of building space, office space, warehouse, all across Manitoba, an asset value over $1 billion. The Manitoba Hydro Place is a successful project, and it really kind of shifted our approach to sustainable facility management in a lot of ways. It's Energy Star certified now at 97 points, so it still is performing after almost 15 plus years of operation. It works very well. But in one really key way, it's been a bit of a failure. And I wanted to kind of tell the story about that failure a little bit and kind of propose some solutions that we can look to for the next generation of high performance buildings. And it's a failure in the really straightforward sense that we imagined that Manitoba Hydro Place would be kind of a flagship project to point the direction to a new generation of sustainable buildings in Manitoba and North America. We've had some interest in the project in terms of folks from Google and kind of these people doing these mega projects coming to see what we've done, but it really hasn't changed the way that we build typical buildings. Now, I went to kind of shortly after we finished our project, Manitoba Hydro Place in kind of 2014. I went overseas and worked for the company that was key to our energy concept for the building, Transolar. Some of you may be familiar with this German consulting company. So I worked there for a couple of years, and it was a great opportunity to see some of the kind of high performance buildings all across uh, North America and around the world. And there was a common theme that I started to learn that was especially prevalent in North American projects. We would often go into a new project and we'd have an owner and a design brief that was really ambitious, build us the most sustainable, highest energy performing, net zero, everything you can imagine would be thrown at it. I specifically remember a particular university in Illinois that wanted we were working on a business school for them, and it was a huge budget, very ambitious goals. And I steadily we noticed that as the project went on from schematic design through design development, at every step of the way, it was watered down. And kind of all these aspirational goals eventually kind of met with the reality of budgets, operational concerns, and so on. I remember being really frustrated, but and talking to kind of one of the owners of Chancellor at the time, who had this comment that the client gets the building that they deserve. And I think that's kind of the theme for my talk today is really about um, educating owners. And I know that there's, every project has owners, there's probably some owners on the call, but certainly consultants that work with owners or contractors that work with owners. It's important to kind of give the owners a few tools. And I'm hoping I can kind of just jump on a soapbox for 5 minutes and share some themes that have emerged as we've tried to develop a more sustainable building portfolio over the last 15 years. And so I'm going to talk about a business case built around the user experience. I don't think there'll be too many surprises in there, but I've got some data to share on that front. I think we really need to, owners need to advocate and demand and ask for and support excellent design. And we also need to focus post ribbon cutting and ensure that we have a team engaged to see through some of the results. So, from a business case perspective, this was absolutely essential to unlocking the ability to invest more in sustainable building at Manitoba Hydro Place. And this is the same kind of business case we use. It's baked into our capital investments justification process now. And I hope this is old news to everyone, but if it's not, then this is really important information. I think it's often overlooked. We spend a lot of time thinking about energy costs, energy savings, but these are really only $1, $2 per square foot per year for our buildings. We're starting to spend more time thinking about space, which is maybe a factor of 10 greater than the energy cost for our buildings, might be 20 to $30 a square foot. And I think that's, I'm seeing a lot of important things about don't build if we don't need it, find more ways of being space efficient. We certainly track space utilization efficiency across our entire portfolio, and we don't build new buildings unless we're getting every last drop out of every square foot of space in our existing buildings. But the big one, of course, which is absolutely critical, and I think consultants need to push this for owners, and owners need to demand it from their design teams, is to focus on the work that's happening within the space. And in my world, is primarily supporting the work of people. Now, of course, this is a notoriously difficult um, uh, uh, item to track from a life cycle perspective. Productivity is very difficult to measure, but we know that the cost per square feet, if I look at a building like Manitoba Hydro Place, any of our other office buildings, warehouses, it's about $250 per square foot per year for the people cost in building. If we can see a 1, 2, 3% improvement of productivity, then we can really start to drive a business case that goes way beyond kind of just the energy savings. And the great news is when we build high quality space for people, it almost inevitably means that we're doing it in a more energy efficient fashion by providing better daylight, better access to views, better air quality, and so on. And that often partners really well with energy efficiency. So, just as a quick example, when it comes to Manitoba Hydro Place, um, uh, we've seen data and we've seen this kind of replicated in other facilities that where it started to renew and put more emphasis on high performance buildings to support human productivity. But we see a day and a quarter less sick time, less absenteeism per person at Hydro Place than our kind of 60s, 70s era stock, which is the majority of our buildings. And that's real savings. That's, a day out of our 200 work days a year. That's already a half to 1% savings just in absenteeism. And I think we all know intuitively that there's additional benefits from being in a place with great air quality, great access to views. We feel more productive and more alert throughout our workday. The other important thing I want to take away, and this is a little bit more challenging to communicate, I think, because I'm still trying to wrap my own head around it, is one of the struggles that we found in um, developing a sustainable building portfolio within Manitoba is we really, and I hope nobody takes it a shot, but I think we really need to push for design excellence um, uh, among our consultants, among our builders. Um, and I want to start with subject to constraints. And it's, there's a quote from the furniture designer, Charles Eames: "Design tends largely on the sum of all constraints." And I think, one takeaway for owners is we don't always do a great job of communicating what the constraints of a project are to our consultant team or our building team. And so in our world, we found a lot of success, and I think a lot of owners are doing something like this. And I encourage, if your owners aren't doing this, then I think it's important that this becomes very prevalent. But the idea of a very simple distilled owner's project requirements, I know Efficiency Manitoba really advocate for this. It's built into the new buildings program. We've adapted and adjusted and shifted our forms. I'd be happy to share. If anyone wants to reach out to me afterwards, if they want to use a template that we've had success with. But it really gets down to no more than 2 pages, exactly what we're asking the design team to achieve, and we want to push them. I think that's really important. This idea that the constraints, as we sort of layer on challenging constraints, it can seem very overwhelming. And I think there's a natural tendency for consultants to push back against these when they find that there's too many, it's too difficult with the budget, it's too difficult with the energy and so on. But if we push the envelope through these constraints, I think we can achieve excellent outcomes. And so I want to show you a really boring example that can kind of illustrate this. And it's the most boring building in our portfolio, probably that you see here. On the left side, we did a building expansion. You can kind of see a little bit of a delineation between a high garage bay and a low garage bay on the kind of midway down the building. That's the addition. Everything kind of to the front of the picture on the left side is an addition. It's just an office workshop, one bay of garage storage, just designed to match the existing building. But we had very ambitious targets in terms of budget, so that's kind of why it's relatively simplistic. It's just a very utilitarian building, but major aggressive targets in terms of building envelope. And we put these constraints in with a relatively challenging capital budget. And what we found is it's sort of this example. If you're familiar with the idea of tunneling the cost barrier, I think this is an old idea that Amory Lovins has put out 10, 20, maybe even more years ago. But this is so relevant and I continually see it missed. I think a lot of times in our projects, as we put more layers, challenges on top, the cost just continually goes up. And you can kind of see this idea of diminishing returns. And a classic example of that is we keep adding insulation and our energy performance improves slightly, but keeps costing more and keep adding more and more dollars and the marginal cost and the efficiency kind of gets worse and worse. We have a difficult time justifying return on investment until we hit a tipping point, and that's the idea of tunneling through the cost barrier. And for that project you saw on the slide before, a really high performance envelope, minimal glazing. That's only where we need it because we only have people working in a particular area of the building. Otherwise, it's primarily workshop and garage storage. Um, that by improving the insulation value, we can get to a point where we eliminate the heating cooling system in this building. And this is exactly kind of the stuff that Lori talked on earlier about the passive host approach. And that's the beauty of the passive host system is it's a very methodical way of tunneling through the cost barrier by having such a good envelope, not to the point that you still need to have a small heating cooling system or the idea is eliminate it altogether. So in this building, we can get away with just a simple ventilation furnace like you'd have in a residential capacity, and our mechanical costs drop dramatically because of the investment in the envelope. And I think that's the idea of these constraints is putting together aggressive challenges and looking for these aren't groundbreaking solutions, but challenging the designers to give us great results. And the last kind of takeaway I think for owners is to really stick with the team to see the results. And this is an outcome from a bit of I think a tough time in the sustainable building world was when New York City made it mandatory to report on your energy data for buildings, and they found that one of the worst energy pigs in all of New York City was the LEED Platinum Bank of America Tower. All kinds of and there's always more to the story than a headline, but studies since then have kind of continued to show that we have on the left side of this graph studies that show that some energy or sort of sustainable lead buildings that are designed with sustainability in mind are better performing from an energy consumption perspective than the norm, but others are worse. It's not necessarily guaranteed that when you go into it with good constraints, the best intentions, good designers, a good design overall, good construction, that you're actually going to see an overall performance. And that was our same perspective with just Hydro Place. And one example is the data from our project. We opened the building in year one. Our first year of operation was about a 35% improvement over the model national energy code, which is great. We're 160 kilowatt hours per square meter. That's a really good performing building, but it wasn't our model target, which was 91 kilowatt hours per square meter per year. And so I really want to kind of share the message that we spend all this money on good designers, on good construction, on all bells and whistles, and then at the end of the project, we walk away and we expect everything to work perfectly. And it's absolutely essential to have the consultant team see the building through a year of measurement verification. For the amount you invest in that phase, it's a drop in the bucket compared to the overall project. And in our case, and I'm convinced that we've seen this, we have seen this in our other projects or smaller examples, and I'm convinced you see this in the majority of projects, that the measurement and verification phase is a steady march of energy performance down to your target. And this savings more than pays for itself when you invest in uh, in good measurement and verification. So that's a high level kind of takeaway for some owners and hopefully some consultants and providers can use this information to educate owners because I'm convinced the owners and clients get the buildings that they deserve unless you're in Lori's position, the enviable position of an owner who is the client who is the designer, which is a really exciting kind of example to see too. So thanks very much, and thanks for all the questions.
Wonderful. All right. Let's get Lori back here and myself. All right. So we've got a few questions coming us to in the chat. And of course, people can add more as well as take yourselves off the mute and raise your hand. So the first question is coming through. How do you deal with criticisms about the higher upfront costs when the interlocutor makes them in good faith or bad faith?
So, I mean, I think buildings are expensive, and I mean, it's partly why I wanted to point out that, there was only $100,000. I mean, only $100,000, but $100,000 is a small amount of money over the life of a building to go from code minimum to passive house performance for the savings that we got. And like, honestly, or the savings that we will get because that's future money. Um, and that is the reason why we do these economic models, because I think most of us really don't understand how we're spending money in buildings. And there's a lot of sort of perceived value in things that aren't that useful comparatively. So, I mean, I just talk about it honestly. And I mean, we did this project because we've had a number of projects that the owners were interested in achieving passive house in a retrofit, but just couldn't make that, couldn't get all the way there. We have on paper, we haven't quite got there ourselves yet. So yeah, I mean, I think it's just understanding what you value and putting the money on what you value. Like, we could have spent a whole lot more money on this project also on fancier finishes and things like that. So yeah.
Okay. So Cam says, I struggle with a deep energy retrofit of our home. Lenders will not value it, so funding is difficult. It is basically out of pocket and likely won't be included in assessed value in the end, where new kitchen cabinets and counters and flooring would. Yeah, that's something we hear a lot. But do either of you guys have any thoughts on that, or have you seen any abilities to kind of work around, or is that just the reality we're all living in?
Well, it is the reality. I do think that it's starting to shift. I actually just this week looked back at the appraisal that we had done in order to finance this project, and the post retrofit appraised value based on the work that we've just finished was in 2021 it was 900 and some odd dollar, on some odd $1,000. And so once we escalate that to the ridiculous rate of escalation that we've experienced over the past 3 years, I actually think that our appraisal was pretty close to what we did. So I'm hopeful that there's a shift in appreciation for for it. I mean, I think there's a lag for sure, but, yeah, I mean, I'm a silly optimist maybe, but I think it's coming.
Okay, so another question for Lori. Given the value of the building fittings and systems, how did the permitting go?
Um, there were no issues with getting a building permit except that Halifax had a massive backlog when we applied, so it took about 6 months, and, if we applied today in Halifax, it might take a month.
Mm.
So it was just, like, peak COVID crazy, when we got our permit, so but no, that what we were proposing was not an issue with the officials.
Amazing. Yeah. We hear a lot of mixed stories about the permitting world.
Hmm.
So for Mark, what do you think of energy performance bonuses built into building designs and construction contracts?
I love this question, and this is I was going to make this point that owners need to bake these constraints that we want to see into contracts. I think it makes a big difference, and it puts a lot of skin in the game for everybody. So we have had success with it lately, and I find it holds the design team accountable lately, and we've done things like a 0.5% of the overall fee. I know we half grades mean it goes from 9% to 9.5% for a particular project or something like that. So it's substantial. It's definitely worth the effort. And what we find the biggest impact is that we attach it to the new buildings program to Division Manitoba, and it ensures that all that documentation and paperwork is being followed through the entire way, and we can. Otherwise, it can kind of be an afterthought. We find if and we have to be in the driver's seat, constantly asking consultants, not all consultants, but pushing the consultants to make sure that they deliver. The bonus makes a big difference to just allow that to happen with a lot of teeth pulling.
Okay, do you guys have any final thoughts? That seems to be the questions that we have there in the chat. All
For
right.
me, thanks very much for the chance.
Yeah, appreciate being here. Thank you so
Yeah,
much.
thank you guys both so much for sharing all of your knowledge and experience. It's always great to hear from other jurisdictions and also about the different types of buildings. So yeah, that's great. Thank you so much.